Hello, dear student. I am Professor Monika Kherajani in the Department of Computer Science and Engineering at Sagar Institute of Research and Technology, SAGE Group. Now, today's topic is Introduction of Compiler Design. Subject is a compiler design. Let's start with the introductory class. Now, first, what is the compiler? Compiler is a program that translates the high level programming language code into the machine code or the intermediate code. As we know that we always write the program in high level language, that is Java, C++, and Python. All these programs or languages are the high level language through which when they are compiled, we get the intermediate code in the assembly language or the machine code. So here the purpose of compiler it's allow the program written in the high level language to be executed on the computer. It also reports the error while compiling from high level to the low level language. Now question arises, why we study the compiler design? As we know that any program which is written in high level language needs to be compiled for translating the program into the machine level language. That's why the compiler are the integral to the language implementation, or we can say that it is the foundation of any programming language. It also helps the programmer to understand how the code execute on the hardware, and it also improves the code efficiency. That means it enables the optimization for the code optimization for the better performance. Now here this is a brief summary of history of compiler. In early beginnings in year 1940s to the 1950s, earlier computer which were used they use the machine code and assembly languages for executing their program, but they were very much complex and error prone. Then in year 1952, the Grasshopper, she was the Navy officer which uh, she developed the first compiler for the AO system which translate the simple instruction into the machine code. After that, in 1954, the first high level programming language that was developed by the IBM, that is the Photon. For the Photon, IBM developed its own compiler, which marking the beginning of the modern compiler. After that, there is a development of so many compilers like in 1960s. It was for the Algol 1960 other programming languages that were leads to the more sophisticated compiler and for the better error handling. Then in year 1970, the structure programming were introduced. For that, compiler were be designed for handles the complex language features and for optimizing their code. Then in year 1980s to 1990s, the object-oriented languages were came into existence like Java and C++ for runtime optimization and for the better code analysis and optimization technique. Just-in-time compilation were be introduced that they were used at the runtime. Like before, all these compiler were be used before executing the programming. Then in this just in compilation were be used at the executing time. Now in after that 2000 at present scenario, the all integration techniques of machine learning are used for optimizing the code and exploring the new frontier like quantum computing compiler are used. Now, what are the types of compiler? There are so many types of compiler are used, but these are the majorly used compiler. The first one is a single pass compiler. Means we compile the code in only one single pass, because there are so many phases are used in the compilation, and only these phases can be used only at the once. That's why its compiler name is single pass compiler. The two pass compiler means when a processor that runs through the program to be translated twice. That's why its name is two pass compiler. And multipass compiler means when we analyze the code in a multipasses to gather the more information. And this is the just-in-time compiler which runs the code at the runtime for the better execution. Now, as you see in the diagram, the language processing system. Now, what is a language processing system? Because when we compile or when we translate the high level language into the low level language, not only the compiler is used for translating the program from high level to the low level. Along with these, also different programs are used along with the compiler for translating the high level program to the targeted or low level machine code. As you see in the diagram, that there is a preprocessor, compiler, assembler, and linker loader. So now when we write the program, when we write the program in high level language, that program is known as the source program. This source program is passes through the preprocessor. Now what is the use of preprocessor? Preprocessor takes the high level program and translate into the modified or pure source program. What does it mean? The preprocessor basically is the integral compiler of compiler, and it is a tool that generates a compiler input. It is a concern with the augmented microprocessing and language exemption, and among the other things. Like it also removes the white spaces, comments, these are not useful for translating the program. That's why it removes or it pre-processes the given program into the pure high level program. Then this high level or modified source program passes to the compiler. As we know that compiler mainly finds the errors, uh, and it is an intelligent program as compared to the assembler. Compiler verifies all types of limit, ranges, errors. Compiler mainly takes the more times to run, and it occupies a huge amount of memory space. The speed of compiler is slower than the other system software. It takes the time because it enters through the program, then does the translation of the full program. Okay. After that, when compiler takes the modified source program and it transfer or translate it into the targeted assembly code. And as you know that there are the three files are used. Like when we write the program and save it, it is the source file. And when we compile that program, it creates the object code, and that is the assembly code. Okay, this is not the executable. And that object code or assembly code passes to the assembler. Assembler is just like it takes the assembly language code and translate it into the language that computer can understand. That is the machine code. The output of assembler, as I already told you, that the output of assembler known as the object code consists of the both machine instruction and the information required to store those commands in the memory. After that, it facilitates the linking and combining of numerous object files to produce the exe file. As we know that uh, when we compile the program, it creates the object file. So that file, it needs to be a executable file. When the source program refers to the library library files, then it is required to link the all object files with the library files to create the exe file. So linker is basically linking the all object files. Then loader is a component of the operating system. It handles the loading the executing of executable files, and it also determines the size of application, freeing up the additional memory. So these all preprocessor, compiler, assembler, and linker loader are also known as the cousins of compiler, which also used along with the compiler for translating the high level program to the low level program. Now, what are the basic operations of the compiler? These are the operations that are done by the compiler. First, it breaks the source program into the smaller part. Depending on the type of machine, it converts the source code to the object code, because code is never be same for the all programming languages. It depends on your hardware and the operating system. It helps in code compilation and error detection, and it saves the all codes which we are using in the programming variables. It can save. It analyzes the whole program and translate it. Now, what are the advantages of using the compiler? First is the efficiency. Provide the efficiency means because it optimizes the code for the better performance. Portability means once any program is compiled, then we can run on any other machine. That's why it defines the portability. Correctness, once the program is compiled, that it ensures that the source code run correctly on the target machine, any target machine. These are the main challenges while designing in compiler. The complexity of the optimization, handling the multiple architecture, error handling is very much difficult, and debugging and testing compilers is very, because debugging means when we translate the high level language into the machine code, so it requires, because we are directly debugging the machine code, it is a very much difficult for debugging and testing the compiler while while checking the low level code. These are the future trends which will be used in a compiler design. The machine learning techniques will be used for the optimization. We can use the AI techniques to improve the code optimization. Parallel compilation is also possible by using the compiling. Means we can speed up the compilation by parallelizing the task. We can build the compiler for emerging the hardware like GPUs and the specialized processor. Okay, thank you so much for the introductory class. In next class, we will on the discuss for the phases of the compiler. Thank you so much.